Part 1. Control motor speed based on remaining battery power. Below the picture is our controllable load, which can achieve the effect of manually adjusting power through the blue sliding resistor, achieve real-time monitoring of power consumption changes. The figure shows the SUI201 model, which is controlled by a microcontroller to display the working conditions on small LEDs. By adjusting the slide resistor, the real-time changes in power are reflected on the display screen. In the video, the current is getting bigger. High power output means that the actual power consumption of the battery is too high. In the comparison chart, the remaining battery power is compared numerically with the points on the right ideal working state line. After comparing the images and obtaining the results, the microcontroller will adjust the output PWM signals to regulate the load speed, thereby making the power consumption closer to the ideal state. The display of PWM signals, we use an oscilloscope to show the duty cycle, demonstrating the real-time control of the motor for the load. This shows the different control methods for the PWM signal under different working conditions. After adjusting the slide in resistor in the parallel step, the current increased, the power also increased, and the remaining power would be lower than the ideal remaining power. Therefore, during the next process, the duty cycle of the PWM will be reduced, as shown by the oscilloscope. The high-frequency signal becomes less. When the PWM signal decreases, the output power for the motor will also decrease, thereby achieving the effect of reducing power consumption of the power supply. This is the method of adjusting the power condition based on the remaining battery charge. Part 2. Parameter measurements during motor drive process. The picture shows that the load end has been replaced with a motor for drive. The picture shows the varying status of steam 32, the speed controller, and SUI201. As shown in the video, when the load end is changed to a motor, SUI201 will be able to test the real-time operating conditions and power consumption. At the same time, the single-chip device will record the real-time status and compare and regulate it.
Okay, so let's start. This 3-in-1 wireless charging module is equipped with 3 independent 15-watt wireless charging channels. It can not only provide fast charging for 3 mobile phones simultaneously, but also be flexibly combined into a multi-device charging mode of mobile phone 15 watts plus headphones 5 watt plus watch 5 watts. It is compatible with all series of Apple and Samsung devices and is compatible with PDQC fast charging protocols. The input voltage can be adaptively adjusted in the range of 5 to 20 watt volumes, and there is no need to specially match an adapter, and it is equipped with an internal magnetic attraction component to achieve a millimeter level precise bonding, paired with a custom Cooper wire coil. It ensures stable and reliable charging for a 5,000 mAh. Here you can see that we have a clock. It means that it is not compatible with this video, this switch. And in terms of safety In terms of safety protection, it is equipped with hardware level OCP overcurrent protection, metal foreign object detection. It means it can stop working when metal approaches, and the automatic power off function in case of overheating or over voltage, providing all-round safety for use. And so, whether it's an office desktop or a car scenario, just a light stick can conveniently charge multiple devices. Okay, thank you.
Now I will demonstrate our power model. Our experimental supplies consist of 3 parts. The first part is a multimeter. The second part is a development board. And the final part is solar panels. Our experimental procedure is as follows. So firstly, connect the positive and negative connectors of the solar panel to the power input. The second step is to connect the multimeter to the output terminal. And all the lines we have all connected already. Now we open the multimeter and adjust to DC voltage mode. The input voltage of the solar panel is 18 volt to 23 volt. And the buck choppers step it down to 12 volt, so which can charge lasering batteries.
I'm Yao Chen. Now I'll introduce our group products. This is batteries, this side negative, this side positive, and solar panels that can supply the power to the models under the sunlight. This is vibration detector and infrared detections. Basically, a person standing by the interface detections can detect it and trigger an alarm. And this interface is disconnected. The enter models will lose powers. By inserting a SIM phone card into the interface, we can receive messages. Then we reconnected the circuit and press the reset buttons here to start the SM models. Please wait a moment. Please wait. Kind of sorry, please wait. It needs some time. And we can notice the night. And the night will be snow. And it will be successful. Alright. The model has started. At this point, as long as the infrared or vibration detection is activated, the phone will receive the messages called the policies. Yes, you can see. Okay, that's all the basic functions introductions of our group's products, using a very small models to achieve remote alarms functionalities. In terms of innovations, it's not only retains the traditional vibration detections, but also adding infrared detections and message reminders. Okay, my introduction is over. Thank you for your watching, and I will disconnect the interface. Bye.